All right, can you hear me okay?
Yes, sir.
Okay. Let's see if I can get my screen shared here and get things going correctly. Let me know if you're able to see this, or if you're not able to see it, I guess. Can you see my title slide?
Yes, it's up on the screen.
Okay, great. Good deal. Well, listen, thanks for inviting me. As Drew said, my name is Bob Henderson. I work for a company called IS4S, Integrated Solutions for Systems. I'm the Vice President of Systems Integration, if titles matter. Just want to give you a quick rundown on what we're doing here and kind of tell you where we've been. Pretty interesting story, and I think we have a good system here that's pretty useful. We started out working with Ms. Lori Miller. She's USDA. I think some of you probably know her. And she was, I'm going to say on loan because I don't know the right arrangement, with Department of Homeland Security back in, I think it was 2012. And we responded to a Phase 1 SBIR, and we're fortunate enough to win that and started doing the research and study work. And then, Phase 2 and other pieces came along. And now we've developed a pretty mature prototype for the portable decontamination system. I'll give you the details of that and kind of how it works. And right now we're going through a 1-year test bed program with USDA on the system. Going to want to process over 1,000 vehicles, get some real miles on it, and find out where it's weak, where it's strong, and then obviously update based on user input and stuff that we've learned here to go to a commercialized product. If you have questions, I have a question slide at the end, or if you want to stop me in the middle, it's no problem at all. I'm glad to tell you anything I know here. I guess first, it's appropriate to address at least the problems that we're trying to help with. There are 3 primarily. The first is livestock farm infections, animal disease outbreaks. I've got a little information here on things that you folks probably know very well, but basically, when these viruses take place, it's an expensive cleanup. Flocks are depopulated. The farmers struggle to recover financially, so all bad. We want to be there to be able to help with the quarantine and decontamination of vehicles as they go in and out, particularly out of a confined area here. The second thing we try to help with are military vehicle deployments. Every vehicle that goes in and out of the country, of course, has to be cleaned and decontaminated. Some of them are very large vehicles, oddly shaped, and doing it by hand is obviously problematic, error-prone, and expensive. So we try to help with these kinds of things. Our system will do up to an 18-wheeler, and we can be adapted very easily to move to wider vehicles if we need to. So that's pretty good. Let's see. Let's go to the next slide here. This is just these slides came out of a different briefing that I did for some investors. So it tries to explain the problems and kind of the need here. From a Wall Street Journal article here back in 2015, there's a quote from one large farmer who spends over $100,000 a month just on truck washing now. So from a commercial perspective, we see big benefit in being able to have a non-portable farm version as a business model as well. And, of course, Tyson's is very interested, and other food producers like them are very interested in decontaminating vehicles that come into their facilities to keep from spreading disease. A good example, of course, is the feed truck that's been, to 5 farms that day and maybe contaminated and you don't know it. He's coming into your farm. You'd sure like to be able to decontaminate that, stop that right at the door. So that's the obvious idea there. There's a third problem that we try to help with, and hopefully we never have to operate with this one, but that is a terrorist event inside the United States. Fortunately, we haven't had any biological events that I'm aware of anyway of significance where we had to quarantine a town or a city and decontaminate first responder vehicles going in and out or personal vehicles, but we're certainly prepared to do that if we need to do that. The current slide kind of shows some developmental pictures. The top right shows the kind of the initial CAD concept. It's slightly different now from where it was, but we do use an inflatable air beam shelter. If any of you have been in the military, have been on military deployments, you've probably seen them. They're very rugged, and the air beams there are a lot like tree trunks when they're inflated. So they're it's pretty tough shelter with doors on the ends that zip up or fasten in some fashion. And that's kind of what we do is we carry that around in our trailer. You'll see that in a few minutes, and along with everything else that we need. And then we have a system where we can actually decontaminate vehicles and catch the runoff and recycle and do those kinds of things so they don't impact the environment adversely. In general terms, the bottom picture down below shows an early developmental picture. The system consists of what we call a gantry, which is the upside-down U-shaped aluminum thing in the bottom right picture there going over the vehicle. This is an early picture where we had just static spray nozzles. We had nozzles mounted to the sides and top that would spray the vehicle. And after some demonstrations and user feedback, we realized pretty quickly that was not going to be powerful enough to do what we wanted to do. So since then, we have gone through a systems upgrade package where we have actually installed robotic arms and a laser scanner and a operator's tablet so that we're able to actually drive a vehicle in. The operator gets out, here's the vehicle. The gantry passes over the vehicle so that the lasers can scan it. The software generates a profile of that vehicle and determines the spray plan, where the arms need to go and what needs to happen. This is shown to the operator. It gets approved by the operator or modified slightly if need be, and then the process is fully autonomous from there. We have 3 software-controlled injection channels, we call them, so we can have any cocktail of soap or chemicals. And basically what happens is we, depending on the threat, we would have soap in one channel and, hydrogen peroxide, for example, or citric acid or something like that in the others. And we would set a concentration on our software, and then I'll show you shortly how we do this, but the system basically in real time monitors the concentration so that we know that we're getting the chemical out to the nozzle that we want in the right concentration. It also helps us keeps from wasting material and also from, again, adversely impacting the environment. We do have a rugged berm on the ground with sides that collects all the fluid runoffs, and we have the capability to recycle those. So we're using quite a bit less water than if we were just spraying and not collecting. I think we're realizing right now something on the order of 80+% reuse of the water. Some goes off on the vehicle, obviously, some stays on the floor, but we're able to collect and reclaim over 80% of it. On a pasture surface, where the surface is not flat, we'll collect a little bit of fluid there that we can't get to with the recycle system, and that's the reason for not being completely recycled. Everything that you see here, plus power generation, everything that we need is self-contained. It goes into a trailer. Right now it's a 16-foot trailer, which is transportable by a 3/4-ton pickup truck on a trailer hitch. Fits into a C-130 and CH-47 helicopters, Osprey, and other things for military deployment if we need to go that route. This slide 6, kind of shows the whole gamut of everything. If you look in the top right, you'll see a picture taken from an aerial drone, UAV, at our first demonstration at the Robotics Technology Park here in northern Alabama, near Huntsville. And at that demonstration, we had first responders. We had an 18-wheeler there, a commercial truck. We had first responders, an ambulance, police, fire department. The shelter you see there is the old First Den shelter. It was just to help us operate for a first demo. It didn't have any end panels on it or anything. You can see the white trailer there beside it, and that was where we learned quite a few lessons. We made, I think, 27 different improvements to the system just from that demo alone, just from getting feedback from those first responders. I'm going to kind of point to different parts of the pictures here. If you look at the very bottom row of pictures, you can see the trailer getting pulled by a truck, and it actually needs a truck bigger than that small Toyota there, but a 3/4-ton truck pulls it well. We've pulled it all over the country that way. The bottom right kind of shows what the system looks like packed away into the trailer. The middle row in the center is if you look closely, you can see it's a CAD design, obviously, but you can see the robotic arms there, and that was the CAD design for the new robotic arms that'll go over that pass over the vehicle. They fold in and go up and down the sides. They fold underneath and spray underneath the vehicle. and that is implemented today. In the middle left, you'll see a picture of the software. This is an older version, but it's very similar to the software on the operator station. Hard to read the gauges, but basically they tell us the pressures and flow rates throughout the system. And the sliders, the horizontal sliders there on the left side of that image, are what allow us to actually set pressure for our pump and also the concentrations that I was talking about earlier for the chemicals that we're dispensing. In the middle right, you can kind of see the business end of everything. What's not shown in there is in the front room of the trailer, behind that big silver box, which is the operating station, there's a large generator, a 30-kilowatt generator, so we carry our own power. The silver-looking box there is the actual operator station where the computing resources are. On the wall there, you can see quite a bit of plumbing. We have reduced the size of that since this picture, but it's actually a pretty good illustrated picture. If you look carefully in the top part of that image in the middle right, you can see boxes, and those are flow meters from the incoming chemicals. So our system has pumps that pump the chemical containers into the flow meters there, and then we have a central flow meter, a little harder to see, that's below that monitors the total fluid going out. So the software monitors the chemical coming in and the total fluid going out, and of course, simple division tells you that what the concentration is, and so it in real time changes the pump speed in minute amounts to make sure that the concentration stays accurate. So we're delivering the right amount of chemical. The middle top picture, kind of boring, but that's the generator that we have. It's an EPA-compliant CAF A3 generator, diesel, can run 24 hours, 7 days a week if it needs to. We've run it for extended periods of time, very reliable, very quiet. The upper left is a representation of our newest shelter, and you can see it's much more robust than the one on the upper right. It has the enclosing doors. You can't see the floor berm from that image, but that one that you see there is 80 feet long. That accommodates an 18-wheeler or anything smaller. And we have a 40-foot version that we're testing or will be here soon to do smaller trucks and passenger car vehicles. So let's see here. The next slide shows another exciting development that's kind of rolled out of this program on a separate contract through DHS. We're developing vehicle decontamination robots. There were two areas that were not addressed very well by the decontamination system I just described. That system, of course, does the outside of the vehicle very well, but the inside of transport trailers, and that you see in the middle picture here, and also the undercarriage of vehicles, we show at the top an aircraft and a passenger car. Those are very complex surfaces, and those weren't being addressed by the system. So we have an ongoing program right now with DHS to develop two separate robots, and we're nearing completion on those with the first round of demos. One of them is a very low-profile, thin robot that rides on tracks under the vehicle. It has a laser scanner, just similar to the automated wash tunnel that I described earlier. And that scanner will tilt back and forth as the robot tracks under the vehicle lengthwise and do a 3D representation of the vehicle. So we can tell then, for example, in the upper right image, you can see the rear differential, the rear end on the car there. We can tell how high that is and how wide and where it is in 3 space. We do quite a bit of software processing on that and then come up with an automated spray plan. So the robot under the car has an arm, a spray arm, a pump, a chemical delivery system, and it's able then to reach into those hard-to-get-to places and make sure that every piece is covered. And this is pretty vital, as you know, to being able to knock off mud and dirt and being able to decontaminate these surfaces beneath the car that normally wouldn't get done with the external system. The other robot is a heavier version. It's about 1,200 pounds. It's on dual tracks, and it's about the size of your desk. I think it's about 5.5 feet long, probably, and on the order of about 4.5 feet tall, about 25 inches wide. Carries 100 gallons of fluids and has its own power generator on it and is untethered. The one that goes under the vehicle is tethered to the wash tunnel system. It gets its fluids and power there. That works well, but obviously for the inside of transport trailers, or as the lower picture suggests, the inside of subway cars or something like that, we need something that's not tethered, because the tethers would be, infinitely hard to manage, I'll say. So this new robot, this vehicle decontamination robot T for transport, actually does the same thing, uses a tilting laser scanner, generates its own 3D environment as it goes into the trailer, and then decides, okay, here's the walls, here are the obstacles, here's the things I need to spray around, and it uses its spray arm to do exactly the same thing, to try to clean and decontaminate the inside of the trailer. One thing I didn't say before that I should say, and this is true for both robots and for the portable vehicle decontamination system, the exterior system, I mentioned water and soap and chemicals, and certainly that's the main staple, but we can also do ultraviolet, fog, steam with simple modification of the arms. We can change the arms and change the source and be able to alter the way we treat the surfaces. So we can do any number of passes over the surfaces, and with any combination of these things that we've been talking about. Let's see here. The next picture, the next slide shows some of the stats. We can decontaminate a 73-foot tractor trailer in less than 15 minutes. That's all surfaces, and that's pretty well unprecedented. Right now, the cost for a passenger car is something on the order of $80 with chemicals, so that's a pretty good cost. As I said, we recycle the fluids. The picture that you see here is actually the operator's tablet. The operator stays outside the shelter for safety and for reasons, obviously, and to keep from getting the chemicals and fluids on him or her. But this shows this pretty good representation of what goes on. Once the operator is out of the vehicle, the vehicle driver is out, the operator then selects something on the screen there, and a scan is made of the vehicle. And those green lines there, obviously representing the vehicle, are the result of that scan. The software then runs by itself and generates the blue line with the red dots there that you see. In this case, that's for the overpass. The system also does, side pass and underpass if it needs to. But the operator can look at this and does a couple of things at a glance. Make sure that the software hasn't fouled up. It's not supposed to, but human intervention is usually a good thing here. Make sure that it doesn't plan to hit the vehicle. And if that were to happen, the operator can touch any of those red dots and move them around or delete them or add dots as needed. So if you had a very irregularly shaped vehicle, or maybe a flatbed trailer that got pulled in behind a pickup truck that was full of junk, that you just hard to characterize, you'd be able to modify the plan there to make sure that you went around it as well as you could. At that point, the operator selects another button, and it's off and running, and then the operator just monitors the progress of what goes on. I think I've talked about already the UV, fog, steam, chemicals, the real-time chemical injection. There are two variants. The portable variant is what was developed by DHS and USDA. We as a company are interested in a scaled-down version of that for a farm-ready variant, which would be obviously much less expensive, and it would be able to target medium-sized and large-sized farms and food production facilities so that you could decontaminate vehicles coming into your property there. Try to knock down the chances of having any kind of infection. One thing we can do, we can run multiple tunnels from a tablet pretty easily. That would be important if you had a very large facility, or if, God forbid, the terrorist attack happened and you had 6 lanes of freeway and 6 tunnels there. A couple of operators could handle, 2 to 3 tunnels each, and it cuts down on the manpower requirements as well. We're experimenting with, haven't been able yet to do a lot of work with, but we believe it's a short hop to be able to do rail car exterior and undercarriage and interior with our new robot with a modified berm. Obviously, the berm would have to accommodate the tracks. You wouldn't want to move the car off the tracks, and we have designed for that. We haven't implemented yet. We're looking for opportunities to do that, but it's a pretty short hop to be able to do that in the rail car station, which is important, as you know. There's a number of other potential uses for the robots, so we're interested in them for that reason as well. We can remove coatings with a water jet attachment. That would be graffiti on the or lines on the street, or runways, or rubber off of runways, or coatings off of a building or a vehicle. Those are a lot of things you can do there. We can also apply paint. We can do the mundane, horrible jobs like asphalt crack filling going down the road and aircraft de-icing and things like that. So there's a whole number of reasons that we're excited about this whole opportunity. From a company perspective, we think there's a lot of commercialization potential as well. Let's see. So this just gives a quick overview of kind of the timeline. As I said, we started out with DHS Phase 1 SBIR. We did the Phase 2 SBIR, did a demo in Wisconsin, and cold weather. I hate cold weather, by the way. We did the upgrade package there. You can see that. That increased the spray pressure, the coverage, the things that we've been talking about. We were one of 5 winners for the DHS CRPP. If you're not familiar, that's a Commercialization Readiness Pilot Program. That really allowed us to jumpstart our commercialization efforts. We spun off a new company called IntegratedDecon.com. There's a website out there. Integrated Decontamination Systems is the company name. We have a utility patent in work. It's patent pending. Hopefully, we'll hear about that pretty soon. And we've developed build instructions, so when we go into production, we'll be able to be off and running. That was a huge help. There's a second Phase 2 that I mentioned that with DHS right now for the decontamination robots, and IS4S has invested untold amounts of money in this thing. So we're over $2 million to date. We've come along since 2012, so roughly 5 years of effort. We're pretty mature. I think the significant thing on all this slide, though, is that we've been really focused, if you will, on customer and user input so that we can get our design driven that way. I alluded to it earlier when we did our first demo at the Robotics Technology Park for first responders. We had about 27, I think, different solid suggestions, and I think we've implemented every single one of them, from increasing pressure and flow rate to how we cover the vehicle to a whole variety of things. And of course, being able to work with USDA and DHS, we get to talk to some of the top foreign animal disease scientists in the world. So that's huge to us to get some guidance and adult supervision from you folks. We briefed the system at 2 international EPA symposiums. A lot of good feedback there. And then, of course, we've had the surveys that I talked about from the first responders. A variety of inquiries that we've had, and we are often asked, when can I get it? When will it be available? We think the first commercial units will be out in the third quarter of 2017. That's our goal, and so that's kind of the plan right now. We'll have internally we're working on getting some investment to mature that from some commercial investors, and to be able to actually have the resources to go out and market this and sell it and set up the distribution channel. I guess this is the last slide here. Kind of reviews the same things that you just saw in different ways. The little picture on the upper right is actually generated by our under-vehicle robot, or at least an early version of it. The silver-looking components is the outer frame of the robot. Obviously, the rest of it has a lot of electronics in it. The blue cylindrical object with a square in the front is the actual laser. The squares that you see on top and down below are what we call voxels. Those are actually the result of the laser scan. So this is kind of what the computer sees when we scan the vehicle. Those squares can be adjusted from, down to almost nothing all the way up to, feet in size. So we optimize our software by adjusting the size of those voxels. We want to see enough stuff that we get it all, but we don't want to see down to the minutia because, of course, it's a lot more data to process. So kind of gives an idea of what we're doing there. We did, as I said, a cold weather test in Madison, Wisconsin in 2015. That was really cold, really windy. Had the old shelter, so it's kind of hard to do, but we learned a lot there and plan on doing another one here in the near future. I mentioned the vehicle decon robots are under development. We're about ready to do a pretty involved demonstration with those as a first outing as well. I think that's all. I'll be more than happy to entertain any questions you have, or be glad to give my contact info if you'd like to contact me later and talk about it.
I have a question.
Okay.
In previous work, we found that one of the challenges we had was maintaining contact with disinfectant for the requisite period of time. For example, citric acid needs 20 minutes at the correct concentration, and we had a really hard time keeping vehicles from drying off. And I noticed you said this wash takes 15 minutes. And if that includes getting rid of the organics as well as applying the disinfectant, I'm wondering what is being done for doing quality control on contact time.
Great question. That's actually glad you mentioned that. The 15 minutes that I gave was the fastest we could possibly do it, the best case, with just soap and water. So that would be rinse it, soap everything, high pressure, and then do a high pressure rinse. What we typically do is when we put the chemicals on, depending on what they are, and that's the reason we don't include it in that estimate, because depending, as you said, on the chemical and the pathogen, dwell time, it was what we call it, would change. So we program in, the operator does anyway, whatever dwell time we want for that vehicle. So we can, for example, a typical process would be we would rinse the vehicle with high pressure, we would soap it with high pressure, we'd rinse it off again, we would then apply the chemicals to all the surfaces and then wait whatever the prescribed dwell time is. Now, we could also, if we had a drying problem, re-wet with chemicals if we want. All that is fully customizable. And so depending on the deployment and what we were fighting and how fast we needed to process vehicles, we can tailor every bit of that. So that's the answer. You're exactly right. Sometimes it's 20 to 30 minutes. We were working with at least one product that was interesting. It was a hydrogen peroxide product that did not require us to rinse. So we put it on pretty heavily, and the vehicle could either sit inside the tunnel or move out of the tunnel and wait, and then it would be pretty well decontaminated under those circumstances. So that's pretty exciting. Obviously, you apply some type of fog or steam, that has speed advantages as well.
Drew, can you hear me?
Yes, ma'am.
Drew?
Yes.
Oh, this is Deborah Nelson. I just wondered if I could be heard. That looks like a really interesting system. My question is, have you done any testing for carbon monoxide generated either by the diesel, which shouldn't be that much, or by the trucks themselves as they go through the tunnel, or cars as they go through the tunnel? Because, tasteless, odorless, you have no way, colorless, you have no way of knowing whether it's there or not.
Oh, good question. The short answer to your question is no. We haven't done any testing per se. We think we should probably do that, but we're operating on a couple of principles here. First of all, the generator stays outdoors. It exhausts. You couldn't see in the picture, but it exhausts upward out of the trailer, and so that's pretty safe. It's a CAF A3 generator, EPA approved. So there's probably not a lot, as you said, not a lot of danger there. Now, inside the tunnel, there's a couple of things to consider. We want to add just a standing carbon monoxide sensor there. We have it on our list of things to do just for safety. But we do a lot of work with military vehicles and a lot of work with University of Alabama, Auburn University, and some other universities on vehicles in a separate part of our company. So how to control vehicles, how to make them more fuel efficient and everything. And one of the things a lot of people don't know is that the new vehicles, anyway, the new passenger cars, are very, very efficient. And one expert there at the University of Alabama said, in fact, you'd be hard pressed to go into a garage and close the door. If you wanted to end your life, it would take a very long time now compared to what it did just even 5 to 10 years ago. But I only say that to say that the newer vehicles don't put out as much carbon monoxide and harmful chemicals as the old ones did. Now, it's worth noting that every time a vehicle enters and leaves, we open up the end panels to the entire tunnel. So there's a huge amount of air when we open that up that gets moved. That helps us as well. And of course, fans are an easy add. But to answer your question shortly, no, we haven't done that testing yet. It is a concern, but we think it's very manageable.
Thank you for
And
that answer.
this is
Oh,
Lori
I'm sorry,
Miller.
Lori.
No, that's okay. I wanted to say thanks to Bob for the presentation and also to you, Deb, for your question. And I just want to reiterate that when the vehicle goes into the tunnel, the engine is turned off and the driver exits the vehicle before the process begins. So the amount of carbon dioxide generation is just while they're driving in and while they're driving out. So it's, quite minimal.
Very similar
So-
to your garage at home, I guess. Maybe less since it's a bigger structure.
Oh, so it doesn't actually move through the tunnel?
Oh, no, it goes in. The driver drives the vehicle in, turns the engine off, gets out, closes the door, rolls up the windows, comes out of the tunnel. The operator then will zip or fasten the end panels to contain, any overspray. And then the whole process begins. That big upside-down gantry, let me see if I can get back to that picture. Yeah, if you look at the lower right picture there, you can see the big silver structure riding down the horizontal track. That structure moves over the vehicle back and forth as needed. The new one now has robotic arms on it that this picture doesn't show. But basically, there's some robotic arms that come out at the rear of the vehicle, let's say, and starts to spray, and then goes over the profile of the vehicle to do the top. And it can do, a variety of passes that way. It applies the chemicals that way. But the motor is not running. That's a good point, Lori. Any time that this is going on, only to get the vehicle in and out of the shelter.
Thank you very much, and thank you for bringing me up to date on carbon monoxide from new cars. I wasn't aware of that. Really excellent presentation and great ideas. Thank you so much.
Oh, thank you. I appreciate the opportunity.
So I have two questions. One is, why does the operator leave the vehicle? It seems like just another opportunity for contamination. And secondly, I'd say $64 question, but I'm sure it's more than $64, is what is the cost on these units?
So this is Lori. I'm happy to take the question about why the operator leaves or why the driver leaves the vehicle. So that was a strategic decision that we discussed at length during the development of the concept. And if the driver stays in the vehicle while the cleaning and disinfection is going on, they have the potential to be exposed to whatever chemicals are being used. So, for example, let's say we're using a bleach solution, they would be in that somewhat enclosed space, and then there would be no way to protect them from exposure to the mist. We talked about, giving them personal protective equipment while they're in the vehicle for that purpose, but then you run into all sorts of issues related to medical monitoring and fit testing. And so the conclusion was that it is safer for the driver to leave the vehicle and wait outside. So, your point is well taken that risks cross-contamination. If the driver has been deconned or never left the vehicle on the infected premises, and if they exit the tunnel on the clean side, then theoretically they're not introducing any additional contamination to the vehicle. But excellent point.
Thanks, Lori.
And then
as for the cost
Sure.
of the units, we're still obviously not selling them yet until at least the third quarter of this year, but we've been working on that. The portable emergency response unit that we've been talking about primarily today, right now the price point looks like it's in the neighborhood of $200,000, and that's the all-up price with the trailer, the shelter, the gantry, the tablet, everything that you would need. So that it's in that range there. Now, the farm variant would be much less. You wouldn't need the expensive shelter or the trailer or probably not even the generator. So that is a $50,000 to $75,000 price point.
Thank you.
This is Carla Tebben. Can you hear me?
Yes.
I have a question about how you know if the vehicle's clean, because a lot of the disinfectants that you use, they only work if the heavy organic matter is all gone. So if the driver is standing outside the tunnel and the doors are closed, how do they know it's clean before they start putting the disinfectant on it?
I can take a crack at answering that one, Carla. Great question. This is Lori. So we had been involved with the Canadian Food Inspection Agency a few years ago on some field trials that they did, and they did extensive testing about the process of cleaning and disinfection. So we had different coupons that were applied to vehicles, and they had bacterial surrogates as well as viral surrogates. The vehicles were subjected to a variety of different cleaning and disinfection techniques, and then the log reductions on those coupons were evaluated. And so that process told us a couple things. First, it told us that there was a minimum 3 log reduction just from cleaning, and it was associated with a visual observation that the vehicle looked clean. So visibly clean was found to equate to at least a 3 log reduction in this test. And then the disinfectants that were used provided additional log reduction, and they varied a number of parameters. And that article, by the way, is under the manuscript is undergoing review by the team right now and should be published, I would say, within the next few months. But so the process was validated, and then the plan is to ensure that the process is followed. So every time a vehicle runs through the unit, it's not being tested to verify that it was cleaned, but periodic, it's being observed to ensure that the process is followed. We would like to repeat those tests with the coupons again on this wash tunnel unit. We did some testing in the Wisconsin 2015 trials. But we would like to do some more comprehensive testing should funding become available. So I hope that answered your question.
Well, what I'm really wondering is, is there like a camera that checks it to make sure that it looks visibly clean, or is there something attached to this that when it goes through the cleaning process, the operator can see that, the mud and the crud has gotten off of it and now it's ready to be disinfected?
So there's 2 parts to that. I'll let Bob address the part that pertains to the technical functioning of the unit and the tablet. But from sort of a process perspective, the operator observes the vehicle before it goes into the tunnel. If the vehicle has heavy caked on mud, then there would be a sort of a triage, using a hand pressure washer to get the heavy soil off the vehicle, the inches of mud before it goes in. Once it goes through the process, then it would be a visual observation. And at this point, there's no photographic component to that, I believe. Bob, you want to expand on that?
Yeah, that's right, Lori. Exactly right. The pictures didn't show, but there are 2 ports where we can hook up conventional high-pressure spray wands to triage a vehicle before it goes in, to knock all the large stuff off and to make sure that there's any concentrated areas, we get that off first. Then the vehicle goes in and gets processed as we've been describing. And we have a capability of web cameras. We used them, Laura, you may remember in our last demo, that lets the operator, make sure that the software is telling the truth and the thing is not running into the vehicle. And then B, it also gives kind of a primary view of whether or not the vehicle is getting cleaned. Now, the other piece that I didn't talk about is the manual operation of the system. If the operator looks from the camera or starts to go into the tunnel and says, big spot here, got missed, the operator can press buttons on the tablet and actually move the arms and the gantry to a particular position and spray that with high pressure, normal pressure, or even higher pressure than is normally used to make sure that all that gets off. One other thing I would add too, this is a thing that we've obviously been thinking about for a long time. How do you know the vehicle's clean? How do you know that you've done a good job biologically? There are two companies here that are working on, they don't have it yet, they're working on fast response systems to detect a whole variety of bacteria and things like that. They've gotten it down to a couple of hours, and we're kind of watching with bated breath. They're saying that they're going to have a near real-time system here in the next year or so. If that happens, then there's a potential that we could actually equip the operator with that device and actually look at the vehicle in a variety of places to make sure that it did get cleaned and decontaminated fully. It would be a more objective measure than what we're doing now.
And to sort of wrap it all up, in summary, in answer to your question, there's two things that would have to happen and to fully ensure that vehicles are being adequately cleaned and disinfected. One is that we would have to do the validation testing, which would match up, the pressures and the spray patterns on the vehicles to a minimum log reduction. So that lab type testing would have to be performed. And then the second part of it would be what was learned from that lab testing, the pressures and spray patterns and so forth, would have to be applied to a protocol that would be used and would have to be followed during a response. So, great question. And those two things would have to happen to fully close that loop.
Thank you.
All right, any other questions? Okay, I think that's all I have. I just want to say again, I really appreciate the opportunity to get this in front of you. For those of you who weren't familiar with it, if nothing else, you can remember that there's a guy that has a thing that does something like that, and give us a call if we can be of any help at all.
Thanks, Bob, very much. Great presentation. And if we don't have any other questions, thank you, sir. Have a great afternoon, everyone.